Hello folks, let's try to do the repeated substring pattern again for a much more efficient solution. So we have done this before, but we have done it in a more very brute force method. But this time we will try to do a more clever solution. And so let's see what we do. So first thing is, it says given a string s, check if it can be constructed by taking a substring of it and appending multiple copies of the substring together. So the thing to understand is that it's not really trying to ask you basically that hey, give me the substring. All it's saying is can it be constructed using the multiple copies of the same substring. So you don't really need to return, like in this case AB, you just need to return true if it can be constructed using a substring of it. Now in this case like ABA, so the output is false because you don't have a string that this whole string can be constructed by appending multiple copies of it. So that is kind of good for us because that kind of simplifies the our headache is a bit lesser in that case because we only need to return true or false. We don't need to return a char, star, or a string. So first thing is let's do it in C++ because C is good. It's kind of a pointer baby, but we want actually C++ because pointers, we will do say C version of this problem eventually one day. If you guys really ask for it, please ask me in the comment section whether I should do this in C. Well, let's do it in C++, and what we're going to do is, as you can see, our prototype is very simple. I'm assuming the interviewer will give you this this kind of pattern saying, hey, please fill this function or write this function basically. It returns a bool and you have repeated substring patterns, string s is given to you. Like in C++, you don't have to do a char star and things like that. So because there's no need of pointers, everything is an object. So string is an object which comes from include string header, but I guess this Leetcode automatically does it for you. That's why it's not showing it to you. So anyway, so how are we going to do this? So the more efficient solution is, first of all, let's think about it a little bit. If a string is made up of multiple copies of itself, of something, not just itself. Basically, there is a substring and it just multiple copies of that substring. Then what could hold? Like, what do you think should happen? Like, for example, if that string is, if you, so one clever solution could be that rather than doing a brute force method of saying if we have a match by building these taking these each character and then adding one more character and seeing if the string is a multiple copies of that substring, and then if it is not, then adding one more to it and things like that. But that's kind of a brute force ON square kind of solution. So here it is, let's do it in a more efficient manner. So what we can do is, so first of all, we need to see is that if a string is empty. So now in C++, you don't have to do things like if s not equal to if s is equal to null or if not s and things like that, because that's a C. C guys do it that way, but it's C++. So you just need to call the empty method of one string object to see if you are paused. So you can say here check for empty string. Now if s is empty, then what happens? You basically return false. Easy, right? Now another thing, what is the other check we need to see? If the string is, so let's do a length, let's find out the length of the string and see if, and for that also you don't need to call strlen, you just call So, like as you know, in all of object-oriented programming like C++ or Python, you just need to call the correct method on that object, and you assume that, or you have to basically look at the properties of that class to see if it has that method defined. So in this case, we know that on a string we can call length. So that is here. So this is how you call you get the length in C++ instead of doing strlen. Now if len less than equal to 1, because what we are saying is that a string of length 0. So let's write, why are we checking this here? A string, if let's first actually implement that, is return false, and the logic behind here is that the reason we are doing that is because we are saying a string. So let's write here a string length 0. So 0, oh, actually I think we have disabled the audio. So if 0 or 1 length string cannot have a repeated pattern, right? So so pattern, let's write pattern, repeated pattern. So those things are out. So we have kind of done our input validation, and so input validation is over, and I think we know that at this point we have something to work with. We are not wasting our time on things which are empty or a string of length 1. So what is the efficient part of this whole thing is that what we do is our approach is the search. So first of all, let's do a create a concatenated string. So you say string concatenate equal to s plus s. Say, this is the beauty of C++. You can literally work as if you can ignore the underlying details and you can just think at the higher level. So as you know, ideally you would like two strings to be concatenated, summed as if they were two numbers. And C++ actually gives you those abstractions by its classes. So you say string concatenate equal to s plus s. Now see, if you were if you were doing all this in C, then you will have a char star for concatenate, and then you will have to do manual memory allocation like malloc of 2 times len plus 1 and things like that. But we don't have to do that because we are lucky to have C++. So after that, how do we find out? So what is the idea here? So idea is we're going to use that, we'll search for the pattern in the search for s. We'll search for s in concat, but the trick that we'll use is we'll use the trick of that we'll use things like concat plus 1. We'll actually search for starting a concat plus 1, but rather than doing str and then starting from concat and looking for s in starting from concat plus 1, what we can do is we can do a concat dot find. See, in C++ you don't have to do a str, you can just simply do a find. So concat, concat dot find, and then we search for s starting at 1. So here the comment should be search for s from index 1 starting at position 1 from the beginning of the origin, the concatenated string. Right. Now see, found equal to concat dot find s1, search for s from starting instead of from, remove the from. Search for s starting at position 1 from the beginning of the concatenated string. Good, very good. Now all we need to do is we need to have a variable known as result. So what we do is we say result equal to found not equal to. Now you see, if you were C, then you would say found not equal to null, right? Because you are looking for a pointer. If the string has a match, if you can find s in concat from starting from concat plus 1 by calling str, what would it return? It would return a pointer. Found will be a char star, and you would say found not equal to null. But this is C++, and the beauty of C++ is you can simply do a found not equal to npos. So npos is basically giving you, like, this is the C++ way of saying that you have to basically it returns a instead of null pointer, it will return the in npos is basically C++ way of saying that there is no match, basically it's not found. So that's all we are doing basically here. So that's your C++ way of saying that the substring s is not found for starting from concat plus 1. Now we also have to see, so first of all, the result is a logical end of these two conditions, basically found not equal to string npos and found. So the actually, if you think about here, the cleverness is basically figuring out that if you can find this string starting from concat plus 1, and you can find it actually before, because you know already that this original string s is starts from like it will start from len, right? Because you have appended it itself, right? So you have appended two copies of len. So but if you find this a pattern, this s is actually found before len itself. That means you have a this string is actually made up of repeated substrings of itself. So I think that is where the catch is, or this is where the cleverness comes here. And this solution is very efficient, very interesting. But in an interview, would somebody come up with this insight immediately? It's kind of doubtful to me, because I couldn't come up with it. And I later realized that interviewer was basically setting me up, in the sense that they were just not telling you the real thing that they were looking for, and they're just making you go in circles and circles, and you think, oh well, I did C++ and I was able to do things like, okay, so here one more thing, it's not yet over. So before we can do a submit, we have to do a return result. Okay, so let's try to run it. Now you're asking me to log in first. So that I will not do right now, but I think this should take care of it. And this is a very efficient and simple way of finding out if a string is basically can be constructed by taking a substring of it and appending multiple copies of the substring together. So with that, I will leave you alone. I thought of creating this video because I previously did this problem, but in a more brute force approach. I don't want to give you guys the impression that here on this channel we only do things in brute force. So we also do things in a more efficient and more better. O notation is better in this case. Basically, instead of on square, you can simply find it in like one shot. So here only thing to remember is that to see if a string is made up of a bunch of a repeated taking a substring of it and appending multiple copies of the substring together is that you look for s starting at position 1 from the beginning of the concatenated string, and if you find s is found before its own copy that we did previously, that means it must have been made up of some substring, and it is a repeated copy of that substring. So if you know that, and if you can come up with that in an interview, I would say all the glory to you. But and I basically wish you all the best, and I hope you enjoy solving C++ or C or any other kind of in these different language, or even Python, these kind of problems, clever problems, which are good for interviews and good for making sure that your creative coding juices are still flowing. So with that, I'll leave you alone. All the best, and I'll see you in the next video. Bye bye.